Okay, so let me pull up, oh, I can't minimize. Okay, hold on. Let me share my screen. Okay, I can minimize that. That's good. Let me open up this right here. Okay, so this is the fifth summer review packet, or the physics final exam review packet for summer 2020. So let's go through this one by one, so you guys know exactly what I'm going to be asking for tomorrow. So I think you guys do bring up an interesting concern that I shouldn't have too many questions that are quantitative in nature, because it does take time to do the calculations, and even for 25 questions in 9 minutes, that could be a big ask. So here's what we're going to do. Take good notes, and I'll kind of use a stylus here, or my stylus is actually not working, so I'll kind of circle red. Definitely I'll expect you guys to know something like number one. I'll do a conceptual question, like, hey, what is a scientific method, or something like that, and it'll be like a bunch of choices, or what's the difference between accuracy and precision. So there'll be something that's conceptual from unit one. I will ask two questions. Actually, I meant to circle 6, 7, 8, 9. So these are kinematic questions. So that's gonna be one question here. And I'll probably ask about two questions from there. So it could be like, you know, here's like the initial velocity, the final velocity, the acceleration, find me the time, or something like that. Or here's like the distance, the initial velocity, the acceleration, find me the time. So it could be something like that. Also, number 10, I will ask them about graphs. So I could, give you something like, hey, here's a velocity time graph, how far this car travel, or something like that. Or here's a distance, displacement versus time graph, what will be the velocity, or at this point. So we've done that kind of stuff. Check your notes. So that'll be one question there. And then something like number 11, with angles and breaking things down to their different components. That'll be another question. Those should be pretty straightforward. Now, for the lab, I'm probably going to reserve the more calculator heavy or computation heavy questions for the lab. And it depends on what lab you're getting, of course. So if you get a lab that's kind of like this stuff here, I think 13, 14 probably more appropriate for the lab simulation. So for the lab simulations, what I'm going to wind up doing is creating a few questions for each one tonight. And I'm going to have to obviously do this for 12 lab simulations. So I know it's not going to be easy, but I'll get it done. So if actually, let me go to my browser here. And let me go to Explore Learning. And say bye. Okay, she's going.
Do you want my paper?
No. Okay. So like, for example, like air track, right? If I click on that simulation, so you can see there are 5 multiple choice questions here. I think what I'll probably wind up doing is I'll probably do 3 multiple choice questions that are probably a little more conceptual, or if you run the simulation, like what happens, just to make sure you can do the simulation. And then I'll put like kind of a longer calculator-based question that would involve maybe a conservation of energy, a conservation of momentum, and you have to show your work. So, and I'll send this to every group. Like I'll send you the lab simulation I want you to do, as well as a PDF of the questions. So I probably won't do 5 multiple choice questions with a free response. I'll probably do 3 multiple choice with a free response for the lab simulations. And that's something you guys can split among, you and the other 2 people. You could probably just really kind of just focus on, or you guys just as a group do each one together. And if you do that, then of course, you might need to take a little time to go through each one and make sure you do it correctly. If you do split the work, you're putting a lot of trust in that person that they're doing it correctly. So I still would advise you that you guys go through your answers and double check and help each other out. Splitting is good, nothing wrong with that. But and you probably get done more quickly. But I would advise that you guys still check each other's work. So that's something just to keep in mind. So I'm going to put the more heavy calculus-based questions. I'll put one per lab simulation, and of course, there'll be some multiple choice questions about the simulations themselves I'll ask you guys. So that's what's happening there for Unit 1. So 13, 14 would be something more like what you'd probably see in a lab that deals with that topic. Let's go to Unit 2. So this will definitely be more conceptual for sure. Actually, let's go red, just be consistent. So for the multiple choice, the final exam, this multiple choice, I'll probably be putting 2 questions that deal with those 8 questions. So I might ask something about the laws of motions as a conceptual question. I might ask something about friction, or there's the mass and weight. So there'll be a couple conceptual questions there. And I really like 11 a lot. 11 I think is a really, really good one. So one question there. And I also like 18 and 21. And 21. Those are good ones also. 18 uses one of the formulas for gravitational attraction. 21 is using the spring. So I'm pretty much just going to change numbers around, just so you know. Just like, hey, instead of 100 kilogram girl, I'll do a 50 kilogram object, and maybe a 150 kilogram object, and then maybe they're 2 meters apart. So I'm not going to make it that much different. So you have that, and then those that might be more. Actually, let me take it back. I'm going to say 20, not 21. Those that might be more appropriate for a lab will be something like 12 or 21. So there was a lab on springs. I probably would put the one on 21 there. There's some stuff on like force and stuff. I might put something like that next to, number 12 next to that one. So just, that's something I'll probably wind up doing on one of the simulations. Let's keep moving. For Unit 3, on work energy momentum. Again, this is going to be a little more conceptual focused. 1, 2, and 3, 2 questions. 7 and 9. I'll probably put a question there as well. 7's conservation of energy, and 9, I think that's on conservation of energy. Let me look at that one. Oh, it's power. That's not too bad. Yeah, a little more formula based. Also, number 12. That's a conservation momentum, and pretty easy one, pretty straightforward. I like that as well. As for what you see in the lab, so there was like the air track one, right? That was one of the labs you did. I might put a question kind of like that, like one of those 2 in one of the lab simulations. So 13, 14. Because those are also involving conservation of momentum. So that's Unit 3. Unit 4, I decided to change things up a little bit. I'll probably put something that's conceptual. Like maybe I might ask you something about equilibrium or mechanical advantage. Remember, guys, it's open notes, so it's not like you have to memorize anything. Definitely a question here. Number 2, I like a lot. I mentioned that already. Something like 5 or 6 with like a seesaw or bouncing on a lever, like that. 9, 10, 11. Definitely a question there that deals with like kinematics and rotation. And then something like 13. We're using torque and moment inertia and stuff like that. I think 14 and 16 are probably want to putting in the lab. So you guys have time for that. And actually the good thing is that by doing the more computation-based, the more intense algebra questions in the labs, you're doing it in a group, right? You're doing it with 2 other people. So I think that's also fair. Instead of asking you to do it individually on a final exam, that's multiple choice, and you're feeling the time pressure of 25 questions, probably better put those free response questions in the lab simulation. So hopefully that makes you guys feel a little better about that. But that's just something we could put in the lab for sure. And we did have some stuff on inclined. So I could probably put that question on the incline one. That's kind of fair. And that had rotation as well. So we have that. And of course, rotation kinetic energy. So that's that stuff. Then let's look at the stuff we're going to talk about very shortly on waves and circuits. Waves is not much. We didn't do too much there. I'm only going to put 2 multiple choice questions on the final exam from this unit. Do expect 1 question among those 3. So something very simple, like I'll give you like the wavelength or the period or the speed, and you got to find like the frequency or something like that. So that shouldn't be too bad. And then something like 15 and 17. Yeah, not 16, obviously. But something like 15 or 17, 1 question there with like decibels or hearing sound. We had formulas for that too. The things that might be a little more lab-based, because we have a lab on Doppler effect, would be like 18 or 19. So in that lab simulation, expect a question there on that. Okay, so that's 18, 19. Let me go ahead and clear this. Lastly, we have circuits. I'm going to be putting 3 multiple choice questions on the final exam, the multiple choice portion on circuits. I like 7. That's a very simple formula. I like 9. That's also just very formulaic. And I also like 12. You'd have to calculate the resistance and then you get the current. So 1 question on each of those. And again, I'll kind of just change the numbers around, you know, then you just work it out. For the labs, because we did have lab on circuits, I kind of like these 2. Like I might kind of give you a schematic of a circuit and say, hey, give me the total resistance and tell me the current that passes through each of the resistors. And of course, you could use a simulation to kind of confirm your answer. Or 13, you know, like, yeah, a bunch of stuff in parallel. I might say, hey, make a circuit with all these parallel resistors and kind of tell me what's going to happen to the total voltage or something like that, or current. So, or what's going to be the power of the circuit. So those are some things I could probably ask guys for the lab. So that's pretty much to expect in the final. This is recording. Watch it tonight. Watch it early tomorrow morning. And just kind of just go through these questions, make sure you're comfortable and understand what to do, and you'll be fine. And again, the ones that are a little bit more intense with the calculations, we're going to save that for the lab practical in the morning, which you're going to do in a group. And so you guys will have you know, you guys can consult with each other to help each other out there. Okay, so let me go ahead and clear. So actually, I'll stop this recording because this is a recording just for time of the final exam, which I'll label it as such. So let me go ahead and